Right, we in. Yeah, boy. In. Hmm. I can't find my Apple Pencil, so give me 2 seconds. I need to find the Apple Pencil. We're gonna do chapter 2 now. Right, so let's begin with chapter 2 now. So we're gonna do see how much we can finish. What we will do is, I think 2.1 is not much to be focused on. I'm gonna put timer. I'm gonna put timer and low music because I just came from work actually. 8 hour. We'll go 8 hour.
Do you realize how much money this will save us?
What's that?
I just built a budgeting app with Base 44.
Right. I think there's not much maths in the. I don't think there's much of math. The heritage of mechanics and whatever. If math is there, let's focus on the math. I'll try to finish 2.1 and 2.2 today. Try to understand what's going on. And based on that, hopefully. Is it like what maths is core here? Like that's what because it's like heritage, 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 heritage. Any core maths to know here from? Because I know it's more about heritage, heritage, heritage and stuff. But just was wondering, are any math? Okay, so abstract. What be the abstract? Use examples for this. You know what? One, let's learn the chapter and understand thoroughly using examples. Using examples like master example. Two, when using master example, let's use this abstract. And as you go along solving the master example, explain what is going on. Okay, less English. I mean, wait, okay. Can we do less English and more math? Why? Because you have so much English that I just can't figure out which ones are math. Now, for English part, have the explanation for the example solving and why you did that, including general equations. Okay, so define the variables. So let's say the state variables x1 is h of t, x2 is v of t. And I'm saying that input u of t is capital T of t. Okay, these are the equation, these are the state variables, that's the input, and these are the parameters. And the general equation, summation of F is equal to ma. The rocket forces would be T minus D minus mg is equal to m dv by dt, because T minus D minus mg is the net force. The torque, the drag force, and the force. And then insert the drag model. So the general drag equation would be half rho C of D AV square. And so we substitute this B minus that minus mg. We replace the general drag force with aerodynamic physics and solve for acceleration. dv by dt is t by m minus that minus g. And so why? Because control theory wants the x dot in respect to f of x and u. we isolate the derivative. Now convert to state variables. We define x1 as h and x2 as v. And the derivative of altitude x1 dot is x2. Because x1 is h, and if I do the derivative for x1, I will end up as h dot, which is v. And the second state equation, so velocity equation, x2 dot would be t minus t by m divided by that, and then that rocket equation becomes x dot being f of x and u. Specifically, x1 dot equals x2 and x2 dot is t by m minus 1 by 2m rho c of d ax square minus g. Okay. Okay. You know what? Add these images to now with the previous images and the new images. Let's do one master example. Have English, that's fine, but don't have English so much explanation that it covers the entire maths equation, right? Now with the previous images and this image, let's do one whole master example. Now explain one step, let me understand, and then next step. Presume I am studying each section while performing each step explanation. altitude, vertical motion, the state variables x would be h and v. H is the altitude, v is the velocity. We have the input u is equal to t, where t is the thrust. And why do we define the state? Because the chapter says system behavior is described through state, and state is the minimum information needed to predict the future motion. So for rocket, currently we have the altitude and velocity that is going to predict the future trajectory. As a general control equation, that okay, this is really good explanation. Wow, wow, this is really good explanation. Like I love it. Sorry if I procrastinated a little bit because today was Valentina's birthday, and obviously I'm not a good man. I'm trying my best. I'm really trying my best. That's what I really wanted to say. I'm really trying my best. I'll do everything in my power to make sure whatever nobody has achieved in 25 years old, I will achieve that earlier. I'll just say that trying my best, trying my very best. I will work hard. I know Valentina hates Muslims, but I still pray for her. I still pray for her. Like, I know she hates Muslims so much, yet I still pray for her. No, she doesn't mind. He knows that. He knows I pray for her. We first define the system. This is chapter 2, section 1. So, first of all, we have to what we call define the system. So, let's say x being h and v. H being the altitude, and v being the velocity. So define the state variables. X is equal to h and v, h being the altitude, v being the velocity. Right? We got our input where u is equal to t, where t being thrust. Now, obviously, why did we define states? Because obviously the system will behave. Now, why define state? Why define states? The system will only be able to behave or predict future through states. If we don't have states, we will not be able to, if we don't have states, we will not be able to predict the future. We will not be able to see what's going on. We will not be able to, predict what's going on. I hate when Valentina follows other people. Like, I know he has a lover now. I know that. I'm not saying she does. I'm not saying she doesn't have a lover. She does have a lover. Literally see it. I can literally see it. But I think people always forget that there was someone who was there, before. Yeah, women will easily forget that. We all know. Oh man. So why do we define states? Because system behavior is described through state. Because system behavior is described through state, and states literally defines the minimum information needed to predict the future motion. So state minimum information needed to predict the future motion. And obviously, in our state, we have what we call altitude and velocity. These are the only two things we have. From our states, we got altitude and we got velocity. Then we got general control equation. So you have dx by dt is f of x and u, meaning the state change depends on the current state and the control input. Okay, so this is, I believe, step 2, right? Step 2. Step 2, our general equations. We have dx by dt being f of x and u, meaning State change depends on current state and control input. So if I have x being so in from my case, I have x being h in u. My x dot will be h dot and u dot, not u dot, v dot. H dot v dot. What do you mean physical rocket into mathematical state vector? Wait. What do you mean by... Let me just finish everything, then I'm going to go back because I don't want to interrupt anything. I have a question here. What do you mean by physical rocket into mathematical state vector? What do you mean by physical rocket into mathematical state vector? Just I need to quickly. I need to do it quickly. then apply the, sorry, my bad, Newton's law. F summation of F is equal to ma. The rocket forces have your thrust force, drag force, mg is equal to m dv by dt. Yeah, we know that. So this will push the rocket upwards. So this will push the rocket upwards. This will drag the, so as it goes up, it's going to force it to go down. Goes up, force itself to go down, opposite forces. I'm currently is it possible to simulate the abstract using like graphs and stuff? Now, I'm also writing a book, and let me actually show you. Yeah, let me actually show you the book. This is the book. Now obviously we have not finished 2.1 yet, but can we still begin chapter 2 if you don't mind? Like, can you do a latex version of chapter 2, like, finish off chapter 2? Like, finish off chapter 2 section 1 and add it. Now, do you know how an academic book is written? Oh no. Do you know how an academic book is written? Okay, don't ask him. Ask DeepSeek. Yeah. Yeah, ask DeepSeek. Always go to DeepSeek. Always DeepSeek. So, currently writing a book, and can you do a latex code for these images? Now write a book, finish, as in, start chapter 2 with this abstract, and the images will correlate to this abstract. I mean the explanation and the maths and stuff. Like if you want, the abstract, can we do a Python program for whatever we have studied, whatever we have studied just now, and maybe get figures, get simulations for our book? If that is all right. Now we want like academic, graphs and research and math, graphs and research, and academic, formal academic research, not kindergarten obviously, but academic, like academic. Oh, it's not going to do the programming. Okay. No, I meant like, can you do the Python program? Can you do the Python program? Because there will be few graphs. There should not be one graph, right? There should be few graphs because, like, you don't see a book having only one graph. Just ask DeepSeek. Now, I do have the Python program that because I want to also add my findings and stuff for the abstract, like few graphs that I did, graphs and mathematical representations I did, and want to paste them on my book. How do I do that? I just did use DeepSeek, literally used just DeepSeek. Yeah, now the worry is that obviously it's not able to find. I'm just curious, like, I'm not able to. Okay, I know they only have one graph. Now, here they only have one graph. Now, ChatGPT only did one graph. Now, obviously, in a book, you are going to have five or six or seven graphs, you know, so that students can see what is actually going on. How do I do that? And add those figures in my book. Can you do it for me? DeepSeek is really good. Like, DeepSeek is really good. Like, DeepSeek is really good, really good. Are you finished? Holy shit, you actually finished. So 2.1 is done. So 2.1 is done, right? Oh, what happened? Oh no. No. Wait. No, 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 no. Huh? But these are the errors. These are the. I mean, I kind of understand why. Oh, okay. Okay, sorry, I'm sorry.